I think it's time. So let's get started. Hi, my name is Rafal. I'm an engineer at Spotify, and in this talk, I'm going to present to you the journey of data pipeline at Spotify, from the time of the inception when we define the problem that we want to solve in data to the time that it makes it to the production. And I will try to present this from the perspective of a data engineer, probably a person that just started at Spotify, maybe knows a little bit about data, maybe not. So you will see how our internal tools work, whether they fail, and why, and what kind of decisions we've made on the way. And I said fail, but actually, I don't know if I agree with that. Like, if I think about data processing, it's a pretty simple problem. I mean, you've got some data, it's somewhere here, then you process it with some kind of framework that you like, everyone has their favorite, and then you basically profit from it. And it's very simple. I don't know where's the whole fuss about this problem. I mean, it's that simple. So let me prove it to you, actually. So at Spotify, you've heard this morning that we're moving to GCP. So there's only like 4 major places where data live. BigQuery, columnar storage, it's fine. Some of that lives in big tables. You can think about it as a key value store. Some of it lives in GCS, which you can think about like a blob store. Some of that is still in HDFS because it's a little bit less than 100 petabytes, so a little bit. So, it's only like 4 choices here. It's very simple, like I said. So then we've got some formats that we use. And initially, we started with text, but then we moved to Avro. That was a great decision. Then we started using Parquet, which also made sense. And now recently we started using Protobuf. And Protobuf kind of makes sense to store it in like Bigtable and GCS. Parquet probably not in Bigtable. So that's still simple. It's fine. You get that. And then on top of that, we've got systems that we can use to process. And that's also very simple. You've heard that there's Dataflow. It's this Google thing. It's managed, it's great. But they also have Hadoop, managed Hadoop, it's Dataproc, it's awesome. We also have our own Hadoop that still lives, it's on premise. Second biggest Hadoop cluster in Europe. It's great. And some of them work on different, actually they all work with everything. But so, it's also simple. It's only like, a couple of edges there. And then on top of that, we've got the APIs, the frameworks that we can use. Fortunately, we've got our own that we've built. It's also great. Some people are still using Scalding. You probably have heard about Scalding. Crunch. Some of them work on different systems. Scio, for example, work on all 3. There's still some people using Crunch. It's bizarre, but they do. So it still sounds simple, right? I mean, it's not that many choices, I think. But to be fair, I think I actually forgot about something, because like if you create a job, you probably want to orchestrate that job somehow. So we've got this thing Luigi that kind of like says what's the job that you depend on and what are the other jobs that want to collect your data. So we do that through Luigi. It's very simple. And then I also forgot that we have this thing Hydra, which is open source is Spydra. And that's like kind of abstraction on top of Hadoop's, different in cloud and on-premise. So it's okay. I mean, it's still not that bad. But we're doing orchestration, but we still need to do some kind of scheduling, right? So, all right, it's okay. Some people are using Airflow at Spotify. That's fine. We have also our own scheduler, Styx. It's great, and you can totally use it. Oh, and also, you probably want to collect some counters from those systems. So we have a service for it. And there's also this thing. And I actually forgot about System Z. So I guess like this is actually not that simple problem, even at Spotify, right? Where all those systems are actually used and you can totally use them. And this is not even everything that is available in the open source world that you can totally still use if you want to. And imagine that you are this data engineer that maybe just started and wants to process some data at Spotify. And this problem, the initial assumption that I had that this face is going to be smiling is probably not correct. It's probably a little bit sad and maybe even worse than that. And you know, how you're making choices and which frameworks you use or which formats you start to use, it can be really tough decision to make, and it's kind of like an information overload, and you get stuck. And what do you do then? I guess the real topic of my presentation should be something like this. But before I try to prove to you that it's actually not right, let me give you some background. So the background is, you've heard that Spotify is a music streaming service. I'm going to skip that part. Another interesting thing about Spotify is we've got a little bit more than, I think, 2,000 employees. And technical teams are usually split into autonomous teams of 7 ± 2 people, right? That gives you about, I think Josh said this morning, around 100 teams. And every single team owns a feature, a part of the system, end to end. Meaning that if, for example, there's a feature called search, right, which allows you to search for a track, then there will be one single team that will own everything about that feature, starting from the backend, starting from training models to give you result, serving them in the backend, also the UIs in all the different clients like mobile laptops, all that kind of stuff, or web. All that is owned by one single team. And that has interesting property together with the Conway's law. How many of you have heard about this one? Raise your hand. Cool. So that's a very interesting law. Basically what it says is, an organization, even an organization, is designing a system, and that can be any system, broadly, speaking. Then the design of that system will reflect the organization's communication structure. And I kind of encourage you to think about, the companies that you work for, and think about the products that that the company is providing, and think whether that is actually true. And it's actually very interesting from the Spotify perspective, where we've got all those autonomous squads. They're pretty small. There's around 100 of them. We use microservices, and they talk kind of to each other through those microservices. The same thing happens with data, where they talk to each other through data pipelines. So basically, data pipeline is the same thing as microservice. Data pipeline has schema on the result. The API also provides some kind of schema. It's kind of the same thing. So that's something to keep in the back of your mind. So now let's talk about data. Let's assume that you are this data engineer or engineer at Spotify that works on some kind of squad, and you need to provide a feature that will touch data in some way. Then the first thing you're probably going to ask yourself is that data already available somewhere? Right? Because if you don't have to do the work, you can just reuse whatever someone else already did for you. And also, this introduced the first concept, which is System Z, or System Z. So System Z, you can think about it as this huge database that holds the metadata about everything that happens under the hood at Spotify. So that's the place where people define their backend services, where people define their data pipelines. And it's a place where you can go and search and maybe find whether someone already provides what you need. That plus some other internal tools that we have. So let's assume that you have this feature and you know what you're looking for. Maybe you're looking for something like top X tracks per user. You could go to System Z and maybe trying to find it. If it's not there, then another kind of useful tool is a data support channel on Slack. Right now, it's a little bit more than 400 people. You can go there, ask any question about data, and there will be a bunch of people trying to help you. It's kind of community-driven, but it worked really, really well, surprisingly well. So at this point, maybe you have found the data that you need, and that's basically the end of that journey. You can just reuse the data that team already computed for you. But let's assume, for the sake of the exercise, that no one actually provides the data that you need. So in that case, you're going to have to use the tools or the data that is provided by data infrastructure. Data infrastructure at Spotify is this kind of organization made out of a couple of squads that provides a couple of things. Namely, they provide you a core data. So that's the data that was cleaned up, it was put in the structure, in some kind of structure, and is in a known location that you can just use whenever you want to compute something from the raw data. Another thing they provide is core tools and libraries that I'm going to talk about in a second. And the third thing that is interesting, they provide a golden path, or something that Netflix talked about some time ago, which is called paved road. I encourage you to take a look at that presentation. We call it slightly differently. Maybe it's a slightly different thing, but we have it for data, or data infrastructure provides it for data. And what do I mean by that? Because like at the very beginning of this talk, I kind of present you with all those different tools. So this paved road looked more like a road, like a really bumpy road where the engineer kind of goes to, and they fall into this crack in the middle of the road, and they have to spend weeks to get out of it because they've made the wrong decision about the tool that they were supposed to use. And I'm just going to try to right now to kind of convince you that this paved road is more like this, where if you get on this golden path, you basically get from point A to B. You get from the point where you define the problem that you want to solve with data, and you get to the point where it's running in the production. How is that working? So you've heard in the this morning from Josh that we love BigQuery. So whenever someone has an issue with data, the first thing that they should do is to think whether they're going to be able to solve it with SQL. If you can solve it with SQL and you can solve it with BigQuery, just do it there. Don't try to be smart. Don't try to, use some fancy Scala stuff. Just go with SQL, and it's going to be fine. You don't have to do much work with it. And it's probably most of the cases it's going to work. Now, not everything is solvable with SQL. Also, even if it's solvable with SQL, at some point this query will become unmaintainable. It's going to be long. It's going to be complicated. No one's going to be able to read it, and it's not easy to test. All that kind of stuff. At that point, you need some alternative to that. That's where scio comes in. And you've heard about scio today. I'm going to repeat that multiple times because I want to make sure that at the end of the talk, you go to GitHub and you actually double check what it is. And you can use this, GitHub has this feature where it's like a star, and and you can press it, it's free. So I will make my day, a lot. So try to use it actually. Try to use that star. So what scio is? So scio is a Scala DSL on top of Apache Beam. And Apache Beam, how many of you have heard about the Apache Beam? Okay, so Apache Beam, think about Apache Beam as kind of unified model to process batch and streaming. All right, and it was open source by Google, scales pretty well. It's a nice model. Has some pitfalls, but we're not going to talk about that because that's not the... there's also a couple of talks about scio. If you're interested in this, you can just Google it. And there's talk about, I talked about it last year. There's talk by Neville. It's interesting. Anyway, scio provides you Scala DSL on top of Apache Beam. It's a generic unified data processing model and integrates really, really well with GCP. All right, so I've got these two options. I've got BigQuery and I've got scio. So if you can solve the problem with SQL, then if you know SQL, that's no problem, no-brainer, you just solve it. If you don't know it, there's a lot of materials out there already that you can just use out of the box to learn how to do SQL. So we're not doing much about that. We do have internally a bunch of documents that specify best practices when it comes to BigQuery, but there's not so many kind of pitfalls to fall in with BigQuery. Scala and scio, on the other hand, is a different kind of beast. So for that one, we provide a couple of things. There's another open source project, Rosetta Code, that you can also find at Spotify organization. What it is a bunch of most common data problems solved in different frameworks. They're solved in scio, Spark, and Scalding. So you can kind of compare which one, what different problems looks like in different frameworks, but also kind of like see best practices that we think can be used for different problems. And honestly, if you walk through all those problems, you're gonna probably, mixing those solutions will probably give you like 80% of all the work that you're gonna do with data pipelines. Another thing, scio has pretty good documentation, and features are either all the features should provide examples. If there are no examples, there are tests for it. So that's how people can kind of look up how they're supposed to use it. But you can kind of like go back to the beginning of my talk and say, Raf, you told us that at Spotify you've got these autonomous teams and they own features from end to end. So what if my team needs to touch the data, but there's no one that knows how to do data, and then you need to do some kind of scio? And then there's also no one that actually knows Scala, by the way. So that's another interesting thing that we do called internal data university. The way it works is we get about 25 people, 25 engineers that know nothing about data, but need to or want to learn data. We take them out of the office. We put them in like a different, building, different room, far from the colleagues, so they cannot go back to work. We get experts in different domains in the same building, and throughout 5 days, we teach them these 5 different things about. So we teach them about functional programming in Scala. We teach them about bash data processing concepts, streaming data processing concepts, storage formats, and serialization. And the last thing is Spotify-specific things. So after this 5 days, they will learn the specifics of Scala that they can apply for data processing, but also the concepts, the most core concepts behind data processing that will give them most of the 80% of what they need. And after this 5 days, they will not only write their own pipelines, they will also schedule pipelines in Spotify, they will process data. So basically, if they actually need to apply this knowledge, they can just go back to their squad, just pretty much copy-paste what they did, just change the logic, apply what they've learned, and they are data engineers, just like that. Surprisingly, it kind of works. We are surprised how well it actually works. Turns out the data engineering is not that hard, maybe. So with that, let's assume that you either already knew how to process data and use Scala, or you went through data university and you've learned. Then how do you start? What do you do next? So I've mentioned systemd, and by the way, systemd is not open source. This link leads you to a presentation about systemd. It's hour-long, goes in depth why we've built it, what are the properties. There's not enough time to talk about it, but I encourage you to go and check it out. So how do you start? Well, we provide you with a bootstrap that allows you to bootstrap your project, and I'm going to show you that in a second. What you get is a pre-baked cookie that gives you SBT setup, gives you a kind of like a template, like an example pipeline, and all that is kind of ready for you to write the logic, write the tests, deploy to production, and just use the data. So with that, I'm going to show you how that would look like. So systemd I've mentioned, is a database, but it also has a nice UI. So if I want to create a new component in systemd, so it's going to be a new component in the backends of Spotify. There's a bunch of templates here, but what we are interested in is our scio pipeline. So I'm going to create one for not another big data 2017, and I'm going to be the owner. And let's see what's going to happen if I press the create. All right. So the component was created, and I got 2 links. One leads me to a project that was just created. and another one leads me to the overview of my new component in systemz, right? Now I don't have time to walk through everything here, but gives this, allows you to have overview of your component, the life cycle, all the information about the owners, all that kind of stuff. We're gonna come back to this in a second. Also, like monitoring, alerting, everything is here. Let's go to our cookie. So once we get the cookie, we probably want to look at what it has inside. So with that, I'm gonna try to clone it and see what's inside. So in the meantime, I'm gonna open it in IntelliJ. And let's see what's here. So it gives me some kind of README that we can actually take a look at. So the README itself, apart from some kind of boilerplate with who's the owner, also tells me what to do next. It tells me to implement my logic. It tells me to implement tests, run the tests, productionize. We're gonna take a look at that. And hopefully after this step, our pipeline is going to be in production. What else is there? How many of you are familiar with SBT? All right. So what you get with the cookie is SBT setup, the way I mentioned it before, which basically gives you a couple of projects. Cannot zoom in. Gives you a couple of projects. There's one project here, which is the pipeline itself. There's a project for schemas, so things like protobuf schemas, Avro schemas that you may want to share with other teams, and some other stuff that I'm going to show you. So remember when I mentioned the systemz? Systemz properties are kind of defined in this YAML file where you can say different things, like for example, who's the owner, what's the name, and blah, blah, blah. That's not probably very interesting, and also you can learn about that more in the other talk. The SBT setup that you get is kind of interesting. Has a couple of projects, including the schemas, like I said before. It's kind of prepared for you to, if you want to use both Avro and protobufs, just in case, you just put the definitions of the Avros and it will get compiled. If it will get published, and other teams can just start using your schemas. The pipeline itself is also ready to use for scio. There is a setup for REPL that I'm going to show in a second. There's also a setup for Docker that we will talk about in a second too. So let's take a look at what the project looks like inside. So this is, I said that there's an example of a pipeline. And in this case, it turns out that the example of a pipeline is exactly what we wanted to compute, which is bizarre. So we're not going to have to actually write the code here. Wow, that's great. So this is the code of scio. Again, we don't really have much time to go into these parts, but this computes the top tracks per user, saves it somewhere. But essentially, as a data engineer, you copy this and you get this working code, then you can just try out. And once you're ready to implement your own logic, you remove this part and you start writing your own logic right here, because you don't need the template. So let's take a look at the SBT again. So what README kind of told me is to try out the template. So let's try to test if the template itself passes the tests. Once we're gonna get that, we're gonna go back to the presentation. All right. So pipeline itself works and has a test. So from this point, you can just start implementing your own logic. Let's go back. you've seen the SBT setup. It's prepared for you. You can start using it from that point. You can start implementing logic, which you've probably learned how to do that through the data university or through the documentation of scio. That's not part of the cookie itself. But also the cookie tells you to do the testing. And there's a test for the pipeline that was shipped with the cookie. But testing itself is not easy, or there's certain fine amount of rules that we want to apply to testing, yet they're not common at Spotify. So therefore, we've got this initiative called TC4D, which stands for Test Certified for Data. And the mission of it is to increase the stability of data pipelines at Spotify through best practices in testing, blah, blah. Basically, it is a program where a squad, a team that owns a pipeline, applies for, they get a mentor, and the mentor, together with the squad, works to make sure that the pipeline applies all the best practices that we have at Spotify when it comes to testing and quality. This program has 3 stages, so you can be certified for the level 1, 2, and 3. If you apply all the kind of steps for level 1, you get a sticker. If you apply 2, you get a hoodie, a beanie, and then hoodie for the 3rd level. By the way, so there's a swag. There's a reason why people do it, I think. But also the interesting part is that you've got this mentor, and the mentor knows how other pipelines are tested, and the mentor is kind of responsible for making sure that you don't get blocked by anything, and also that you actually apply the best practices. And if you get certified, there's an email sent, everyone celebrates, there's a cookie. Things like that. All right, with that, I want to mention another 2 open source projects. It's kind of like a thing, I think, with open source project in this presentation. They all have the stars, too. Another thing, when you compute some kind of result, as it turned out, when people started computing some kind of results and saving them to like GCS, which is Google's blob store, it wasn't easy for them to kind of like look into what was the results. And if you're familiar with things like Avro tools or Parquet tools, those things don't work out of the box for GCS. So we spent some time and we implemented this thing called gcs-tools, which basically provides exactly that. Gives you a way to easily look into Parquet, Avro, and Propertybased that live on GCS. It's very simple, but it's also very useful. Another thing, ratatool, which goes back kind of to the testing and best practices. So ratatool is another open source project. This one provides a couple of things. The biggest ones are there's a set of samplers for different formats. There's a job that allows you to compare 2 results of 2 different pipelines. And the third thing that I want to talk about is it provides you an extra utilities or helpers for Scala check. And how many of you are familiar with Scala check or property? Okay, so Scala check is a property-based testing framework for Scala. And so how many property-based testing, how many of you are familiar with that? Cool, so that's good. I have an example of that, so no worry. So normally what you would do in a unit test would probably look something like this, right? You have some data that you hard code. That's your test data. That's the input, right? That I hard coded. I spent a lot of hours thinking about these values for my test, and I put them manually. So I put an actual labor in there, and then I somehow came up with the results that I want to get out of that input. And this, you can think about it as kind of like a unit test where I put the data that I handcrafted myself. I handcrafted the expected, and I put it through some kind of, in case of unit test, it's going to be a small piece of code, and I give it the I give it the input, and I expect certain output, and that's how I test. Turns out, maybe there is a better way in certain cases. So what property-based testing kind of suggests to do is to instead test properties of, your functions or code. So in this case, there's an example of property test for concatenation of strings. So what we're saying, if you're not familiar with Scala, that's fine. We're saying property concat with concatenation means that states that for all two strings, A and B, if we sum them together, which is concatenation, we expect the property of length. So the length of the result should equal the sum of length of the strings before we concatenated them. That makes sense, right? And you've probably noticed we did not say what's the input. We just said what are the types, right? So Scala check itself comes with generators, what they call generators, that will basically fill out these strings with some generated values, right? And it will try to do things like weird things like empty string, very long string, and things like that, like a corner cases that otherwise you would have to implement yourself. And runs this for like, you can define this. Default one is probably runs 100 tests, right? With like weird data that can be in string. Now, this is an example for a string, but what ratatool gives you is ability to, instead of this being a string, maybe that could be a protobuf, or maybe that could be a navro of your very complicated schema, that instead of you having to hard code those values, you can just let the framework put those values in that schema. And then you just kind of test the properties that you expect on the results of a pipeline, a function in the pipeline, and so on and so on. So that's what our ratatool gives you. With that, we can slowly move to the production and the last life cycle. Any questions at this point, by the way? No? So at this point, we've got our pipeline, we've implemented our logic, we've tested it. Maybe we went to a TC4D, we went through the certification. Everyone at Spotify thinks this is a great pipeline. It has some kind of level, let's say level 2. So we probably want to make sure that, we want to put it in production somehow. So I've mentioned that, so at this point, I probably should go back to the cookie. But what we're going to talk about is a Jenkins setup with job DSL that you can check out, the setup with Docker, and the lifecycle through systemc. So let's go back to the cookie. So the cookie itself came up with a couple of projects, but also has this interesting folder here called .spotify and has a couple of files inside. So this is the job DSL that you can use for Jenkins, which basically allows you to define how the workflow should look like in Jenkins without you going to Jenkins and clicking things around. And you get that automatically for free. So let's actually take a look at how would it look like. Fortunately, I've got a Jenkins that I can use, and we'll show you how it would look like. So I've got this project where I can build a new pipeline in Jenkins by running this project in Jenkins. So you remember when we got this repo in GitHub. Well, we have to specify the organization, which in this case is RAF, and the name is the name of the repo. Then if I click build, well, I should get a new project here. And you can actually see it over here. So what happens here is there will be a new project, it will be checked out, it will be built, it will be tested and deployed. So at this point, my pipeline is registered somewhere, and in this case, I need to go back to the SBT setup. Because what does it mean that it is deployed is the question. So I've mentioned that there's a setup for Docker, right? So every single pipeline is packaged in a Docker container. And how you can create a Docker container? Well, in SBT, it's very simple. You just run Docker, and this will put the whole pipeline into a Docker container. Will create the container, and then you can ship it to the registry, or you can give it to another person. That person can run that pipeline. It's totally isolated. Whatever you have in that pipeline will live in that Docker. That also means that after the Jenkins runs, that Docker container is registered somewhere, so that maybe something can actually run that for us. So that goes back to the systemz. So in systemz, if I check the okay, this is going to be a different. That's fine. If I check the component, I might be able to see a couple of things. In here, I will be able to see a Docker image that was registered for that component. And then the only thing I have to do, and a couple of parameters here that specify, for example, how often should I schedule this pipeline, which in this case, it says days, so it will be daily. So the only thing I would have to do in this case to enable this to be scheduled is to, well, press this. And now this pipeline is going to run every single day using that Docker container, which, by the way, you can totally run locally too. It's the same kind of isolated environment, so you can totally replicate what is happening somewhere in the backends. And that kind of goes back to the lifecycle. So you've probably seen this graph earlier today, which is dependencies. I'm going to show you really quick. So dependencies, as I said before, are defined through Luigi. And the way that happens is through Python. So in this case, it's a scio job task, has some kind of parameters here, like a project that runs, parameters for scio, but also the dependencies itself, like things that it requires. It requires some kind of, some kind of endpoint that has this ID, and it outputs this endpoint that has this ID, blah blah blah. So other people can depend on you. And you also depend on another project. So that happens through Luigi, and you end up somewhere, somewhere here, right? Because you depend on something, and other people depend on you. Now, remember when I pressed the button, and I said that now everything is scheduled? Well, that happens through styx. And styx is a scheduler that we have that basically, allows you to do kind of cron through Docker containers that run on Kubernetes. It's that simple. It has nothing to do with data pipelines. It just happens that we package data pipelines inside of the Docker containers. Right? But also, that makes it very flexible too, because you can put whatever you like in that Docker container. As long as it has an entry point, styx doesn't care. It will run it. If there's a result of 0, styx will be fine. Now, going a little bit faster here with, that's not the end. Because we still, we have our pipeline, we wrote the code, we've tested it, it's certified, we have Jenkins that is building the code, publishing the Docker container. We said, styx, you should schedule this every day. But that doesn't really mean that the pipeline will run every single day. What if there's no dependency? What if you're waiting for something for days and you're never going to see that? You probably want to be notified about that. Or what if something happens with the pipeline? What if there's a weird state in your pipeline that should not happen? You probably want to know about it. That's where Datamon comes in. Datamon is not open source. This leads you to another presentation by my colleague about Datamon. 1 hour only about Datamon, so I do recommend that, which basically what it allows you to do is, if your pipeline fails for some reason or is late for some reason, this will notify you. This will notify you through things like PagerDuty, email, all that kind of stuff, whatever you like. So lateness and, return code of non-zero is one thing. Another thing is, what if something inside of the pipeline happens that you don't want to happen? So historically, starting from Hadoop, this thing was achieved through counters. And we have also a service that allows you to monitor data counters and alert on them, because that's what essentially you want to do. You want to make sure that you can alert in cases that counters have invalid values, for example. So in that case, this is the view that you get from Datamon. All this kind of integrates through systemz. So if something is defined in systemz, you're going to be able to see it in Datamon. If you have counters, you're going to be able to see the values in counters over here. Just quickly, Over here you see all the partitions, kind of executions for every single hour in this case. And then over here you can see a graph of a specific counter. And in this case, it goes up and down. But you can, for example, you could have a counter. In this case, we could have an alert that says that this value should not go above, 50 billion maybe in this case, right? So that could be a meaningful thing for you, and you could define this kind of alert. If it goes over that, well, there's something wrong with your pipeline. You get paged, and at least you know. So we're almost there. And these are kind of like a high-level kind of lesson learned, maybe. Apart from the tools that we've open sourced and we want to get your feedback for, we want to kind of like give this paved road. It's not necessarily there yet. It's still complicated. It's still not easy, even if you work with this for a while, to explain to people. But we want to make sure that there's kind of like this paved road is pretty straight, and there's less and less of these intersections in there, so you don't have to stop and think what's the next step. And as we're building these tools, or as we are designing API, for example, for scio, we want to make sure that easy problems are easy to solve. So we don't necessarily want to be generic as much as possible, but I want to make sure that things that are easy, that people mostly do, will be just there available for them to use. And that goes for the tools, that goes for the APIs. But at the same time, there has to be the advanced problems, and the exploration and alternative solutions should be possible. And not only that, should be encouraged. So if people want to try different things, if people want to try Airflow, which is completely diagonal to Luigi and orthogonal to Luigi and Styx, that's okay. They should be able to try it out. Not only that, they should go try it, and then they will learn something new, and they probably will bring some kind of new knowledge back to us, and then we can use that knowledge. So we all use kind of like a shortcuts. If we know the shortcut and we don't want to go through the road because maybe there's something that we know it's not going to work for us. That doesn't always work, but we always learn from it somehow. And then this is kind of like a list of open source tools that we've talked about here. You can check them all out, especially the first one. If I haven't mentioned scio yet, and I encourage you to take a look at it, provide feedback, try it out. If it doesn't work for you, let us know. We want to fix it, and I'm open for your questions.
Hey. Hello? Okay. Hey, so I have a question. On the, when you're in your big nasty dependency graph, and something's broken in the middle, and it's been detected that it was broken sort of in the past, something like post facto, somebody realized that there was some corrupted data that was produced 2 weeks ago, and it affects a large portion, a large slice of that graph. What's the model for orchestrating the reparation of that, repairing that, sort of healing that portion of the graph?
Yeah, I guess. The way it would work is, first of all, it depends how big the impact is. It was a case where a thing would not work, but it would not be that big of a deal, and the decision would be just like, okay, we can live with this. If the data has to be recomputed, then the partitions have to be removed, marked as not available, and then Styx will kick in and recompute everything. Luigi and Styx will kick in and recompute everything. So it will be like a backfill.
But then how does that overlap with people using Airflow?
In that case, people using Airflow. So that's the interesting thing. So if there's this intersection of people using different tools, well, that's probably not gonna work. So that's the paved road, the golden path, right? Like if you are on it, you are covered. But if you choose to use a different tool, then it's kind of on you to make sure that if things happen, you have to fix them, right?
And then, sorry, one more thing. Is there, in the different workflow projects, are there ever sort of, I imagine, at least here, there are certain projects that are touchier than others, right? That is a little bit more difficult to orchestrate. For example, you can quickly, it's complicated to load data into some sort of SQL server, some sort of, you need to not, you can easily break downstream systems and things like that. If you blindly let a scheduler like styx just have at it, how does that, do you have that problem, and how is that handled?
So I think, so interesting thing is like going back to the fact that squads themselves will own the system end to end, right? So if they do some kind of ingestion to some kind of database, they own the database, right? So in that case, they make sure that they don't overload things, right? So in case of let's say ingestion to Bigtable, right? They will make sure that there's only one job running at a single time, and they will make sure that that ingestion happens as fast as possible, and that's doable through styx and making sure that like for example, data flow ID is set to like a specific value. Then the system itself will not allow you to have multiple jobs with the same like ID, right? So there are these primitives that allow you to do these things, but as a team itself, or squad owns the system end to end, they are responsible for it, and there probably will be no other team that will like hammer their Bigtable cluster. Any other questions? That leaves us some time to go to GitHub. Actually, so how much time do you have?
I think it's coffee break right now. So.
Oh, it is overtime?
I think so.
Oh, damn. Okay.
Oh, no, you have 2 minutes.
2 minutes? Okay. Now, I actually wanted to show you. So you remember when I said that scio integrates very well with BigQuery or GCP? I wanted to show you how well it integrates with BigQuery here. So if I go back to my pipeline here, I can replace this. Now what happens? White space. Well, we also have style. So cookie itself comes with a style check that is on the error level. So whenever you make a error in style, where the Jenkins itself will fail, by the way. So there's no warning. Warnings make no sense. Never for style. So you should only be able to error on style. So that. Let's go back. I need to do it. Let's rebuild this. So in this case, we've got this BigQuery query over here, and I wanted to check I wanted to check who from Criteo is contributing to GitHub. So BigQuery provides this open source, provides this open data set called commits. So I can look at the commits and look at the outer email of that, and if it ends with Criteo, I'm going to assume it's from Criteo. So that, why did I build it already? So then what I can do is I've got this big GitHub class over here, and you can see that there's no body here. It's just an interesting part. Then what I can do, I've got scio context, and I say my input is from type BigQuery, and I specify the class over here. What happens, that class is actually generated at a compile time through a macro. What happens in the macro goes to BigQuery, fetches the schema, and implements a case class for this, together with a companion object. And then what you can do is, you can see over here that I get this map. I can do a map of element, and I get the name out of that element. And you can see that I get dot over here, and I can actually do outer. And that outer is of type, you cannot really see it, but it's of an actual, unless you can see it there. But it's an option of an outer. So it's an option of an actual class. So all this thing is type safe, even though all that data is stored in BigQuery. So you're totally safe at the completion time here. And I'm not going to have time to run this, but I bet that Justin will be somewhere there. So thank you.